Okay, before we do our first example of a linear model here, I want to remind everybody of some things about watching these videos. So you'll get a lot more of it if you do more as opposed to just taking it in passively. So you might need to pause it frequently to stop and write things down. You might need to rewind it frequently. If you're on a computer, you can rewind by just pressing the back arrow button. That will go forward either 5 or 15 seconds. I don't remember exactly. And do as much as you can from all of the problems on your own. So whenever I'm about to work something out, if you can pause the video, try to work it out yourself first, you'll get a lot more out of it. It might take you twice as long, and that's okay. The videos are much faster than it is in class time. So, for example, if this is a 5-minute video, you should be taking about 10 minutes to really go through it properly, to really be trying the problems first while it's paused. It will take a little bit longer, but it's worth it and you'll get more out of it that way. Now, let's actually look at this example. So, the first thing I need to mention here is that when there's a bunch of stuff to read like this, I'm not going to read it aloud because that might be kind of boring. You guys know how to read, so try to read it at your own pace, which might be slow, it might be fast, while the video is paused. And in a moment, I'll assume everybody's read it, and I'll start talking about how to approach it. So pause here to read, and in one moment we'll get started. Okay, now that you've read it, let's start with part A. It says to make a table of values, so we want to think about how the cost changes as time changes. So if you're not sure where to start with this, a good place is just to start by making a blank table, which will look something like this. Always a good idea to include units with all of your numbers. So for example, T represents the number of hours that you ride the bike. C here represents the cost. And if you don't know what numbers to start with just the start with some values of time. That usually represents an input thing. And what makes sense as a number of hours that you could ride a bike, you could ride it for 0 hours, or 1 hour, or 2 hours, or 3 hours is a fine place to start. So in this case, let's see what is the cost going to be using the description for renting a bike for 0 hours. So this question is about the community program. So the information here about this in Lyons, France is actually kind of irrelevant for this. So if you rent a bike for 0 hours, this means that you paid the $5 subscription fee, but you didn't actually use the bike, which a lot of people who sign up for gym subscriptions are familiar with. You pay the subscription fee for the gym, and then you don't end up going. That happens to a lot of people in January. So in this case, you're gonna still have to pay that $5, but you're not paying any for the rental. So now, if you rent it for 1 hour, you're gonna pay the $5 plus the $3 for 1 hour. So that's gonna make $8. If you rent it for $2, that's going to be 5 plus $3 for 1 hour plus $3 for another hour, which of course you could also write as 5 plus 2 times 3. It's the same thing. And either way, it's $11. And for this one here, if you rent it for 3 hours, you're doing the $5 subscription fee plus $3 per hour times the number of hours is 3, so that's going to be 5 plus 9, which is $14. Now for part B, to plot these points on a graph, what we need to do is, what we're going to do is first realize which is going to be the horizontal axis and which is going to be the vertical axis. Oops, it's the wrong So we're going to have a horizontal axis and a vertical axis. The thing that you want to be represented on the horizontal axis is going to be the thing that you're sort of thinking as input here. And I mean input in the sense that you started with these numbers and then you did something with them to calculate these other numbers. Usually it's going to be time, if time is one of the variables. So we'll write t. It's always good to include the units with it. And the other variable is like the output one, the result of these calculations. That should usually be the y-axis, the vertical axis. And then you need to set up your scale so that all of these numbers can fit. So like so. And this might take a few tries to get it looking good. If you're using graph paper, try to use the grid. The important thing is that the distance between each unit horizontally should be about the same, or otherwise it's going to look really bad. So here I have 1 unit from 0 to 1. It's the same distance as I have from 2 to 3. A really common mistake for students making graphs is to make from 0 to 1 really big, and then they make every unit smaller after that for some reason. So that's going to give you a weird distorted graph. So don't do that. So here we've got our axes set up. Then let's put the xy points, or in this case the t-c points. So we have when t is 0, c is 5. That should go right here. When t is 1, c is 8. That goes right here. When t is 2, c is 11. There. And then when t is 3, c is 14, which is about here. And then if we want to draw a curve through them, and a curve in math includes straight lines, but that's what we've got here for our curve, our so-called curve. Sounds good. So now let's write an equation for c in terms of t. Now this is an important bit of terminology I want to focus on here, is what does it mean for an equation to be written for c in terms of t? So in general, for c in terms of t means you want to have c by itself on one side and then equals so that there's some big expression on the other side with some math that just tells you what to do to t in order to get c. So the idea is that the t here is like the input in this kind of equation if it's written in terms of t. And the c is the output. It's the result from doing those calculations. So that's what it means to have an equation for c, is it means it should look like c equals. So that's the goal here, is to get that kind of equation. Let's see how we can do it. Well, what are we actually doing when we calculated these values of c? What did we do to the number 1 to get 8? Well, the number 1 hours, that meant that we pay $3 for that 1 hour, because it's a cost of $3 for each hour. So we started with $5, and then we added something based on how much time there was that was spent on the bike. So if you spend 1 hour on a bike, you add the $3 once. If you spend 2 hours on a bike, then you do 3 plus 3, also known as 2 times 3. If you spend 3 hours on the bike, then you do 3 plus 3 plus 3, also known as 3 times t. In general, what we're doing with all of these is we're taking the number of hours and we're multiplying it by 3. So we can write that as 5 plus 3 times t. And that is an equation for c in terms of t.